Hello and welcome everybody to our workshop, Prevention Engineering, using our open source tools called the RPC Firewall and the LDAP Firewall. My name is Segi Dulce. I'm the VP of Research here at Zero Networks, and I've been doing security research for the past couple of decades, covering all sorts of topics from data protection through containers and network security, reverse engineering, and in the past years, writing a lot of open source tools, some of which we'll be seeing in this presentation.
I'm Dekel, a senior security researcher at Zero Networks. I've been in the IT and cybersecurity field for the last 15 years, working on both offensive and defensive security projects throughout my career. Together with Segi, I developed various open source tools, namely the LDAP Firewall, which I will present for you today.
Great. So what we're going to cover today, this is going to be a session with a lot of hands-on experience, obviously. But first, I do want to start with a demo, show you the why it's interesting to use our open source tools and how many attacks they can actually help you prevent. Then we'll talk a little bit about prevention engineering, what it is, and why maybe you should be using it in your environment. And then we'll walk you through each of the tools, the LDAP firewall and the RPC firewall over domain controllers, and show you how you can configure them to make them effective tools in prevention engineering and stopping a lot of different forms of attacks. So let's get started with a demo.
So now we'll try to run some LDAP attacks. This is our attacker machine. We'll start off running Bloodhound, so using the Sharphound collector, which is usually the first thing you'll do as an attacker. And we can see that we are getting no results back, even though any user should be able to do this. We're still not getting anything back because the LDAP firewall is stopping all of these queries. Next, we'll run get users SPN, which is used for Kerberos attacks. And we can see that even though there are some users with SPNs, we're not getting any results back from this tool. Lastly, we'll run PyWhisker, which is used for shadow credentials attack, basically trying to modify an attribute. But again, we are blocked from doing this modification. So if we open the event viewer, refresh it, we can see what these queries actually look like behind the scene. So first of all, we can see that some legitimate searches were not blocked and everything is working correctly. But here we can see a search that was blocked. This is the Bloodhound search. We can see all of the different attributes that Bloodhound queries for. And even though we're running with a high privilege user, this search operation was blocked because it's associated with Bloodhound. Next, we have this operation, which is for the get users SPN. You can see the service principal name attribute queried. And then here we have the key credentials link, which is part of the shadow credentials attack. So this notification was also blocked.
So first we look how the RPC firewall can block a lot of type of attacks. We'll use a few examples. We'll start off with Mimikatz trying to do a DC sync attack. And even though I'm domain admin, you can see I already got access denied. The second attack that we'll try to do is to execute code remotely using psexec. And again, I get the same issue. I get access denied. And last but not least, I'm going to run the Coercer tool, which uses a lot of different RPC interfaces. And for each one, it's trying to create an NTLM relay attack. And you can see from the output, there's a lot of different interfaces, a lot of things that it's trying to do. And basically for each one is getting access denied, access denied, access denied. Great. So now that we saw prevention engineering in action, I think you sort of have a good idea what it is. It's not rocket science. Prevention engineering simply means that you have to decide if you want to stop an attack, or can you, more accurately, stop an attack. If no, maybe it's worth maybe not doing anything. If you're using classic detection engineering, you may be collecting a lot of logs, creating a lot of rules, um, and this could be all well and good. But the question is, do you derive enough value from it as opposed to how much effort you put into it? And sometimes the answer is no. Like the amount of effort that you put into detection engineering could be huge, but eventually you have to ask yourself, can it actually block an attack? Would I respond? Maybe I would only respond hours or even days later. And by then, maybe it's not even worth the effort of detecting. So things like DLL injection could be very hard to actually detect and even harder to block. Credential dumping, same thing. And C2 communication, also notoriously very hard to detect and block. But if the answer is yes, maybe there are attacks that you can block, and some of those we just saw in the demo, like disenumeration, various coercion attacks, dissync, and so on and so forth. If you can block them, then it's worth the time, it's worth the effort, so you should go ahead, block them, and very importantly, also create an audit trace that will help you obviously pinpoint who did what and help you further isolate this attack. And this is, in a nutshell, prevention engineering. So focusing on prevention, blocking and auditing, and not on simply detecting attacks after the fact.
LDAP is the protocol that lets you interact with the Active Directory schema. This could be for reading information or writing information, all of the information about the users, computers, groups, permissions, all of those things. LDAP is used very commonly in the Windows environment. For example, if you open up Outlook and look for a user, so let's say you're searching for me, you would write DE and hold Control K. Behind the scene, there will be an LDAP operation or LDAP search operation that goes to the DC and queries for any user that matches the DE string. And LDAP lets you do a bunch of different operations. It could be search, add, modify, delete, and so on and so forth. Now, if you look at the LDAP directory structure, it's basically built like a folder or directory. On the top, we have our company domain. So in this case, it's company.com. Under that, we have different OUs, which are like folders. In this case, I have a London OU, I have a New York OU, a Paris OU, and so on and so forth. So basically, these are different branches that I have in my company, but you can create any that you want. And under each OU, we have the different objects. So in this case, we can see a user called John Doe on the left. We also have groups here. We can also have computers and different things like that. If you want to refer to a specific object, the way we do that is with a DN or a distinguished name. So this is the long string that you see on the bottom, and it's usually easier to read them from right to left. So if you look at the end, we see DC equal com, and before that, DC equal company. So that's our domain component. So that means we're talking about the company.com domain. Before that, we have OU equal London. So we're talking about the London OU. And before that, the common name John Doe. So in this case, we're talking about the user John Doe that is under the London OU that is inside the company.com domain. Now, each object can have different attributes, which are fields that hold data. This data can be a bunch of different things. So in this case, we have the given name John, the last name Doe, telephone number, a mail, the object class, which basically specifies what kind of object this is. There are a bunch of different attributes. This is just a small example. And in Windows, there's a bunch of different ways to see that. On the left, you've probably all already seen this before. This is from the Active Directory Users and Computers tool. If we go to the attribute editor, we can see a bunch of different attributes. And on the right, we have the same thing using PowerShell. So in this case, it's get AD user, which returns some of the relevant attributes, not all of them, but you can see some examples below. Now, why is LDAP important? Why are we even talking about this? Basically, one of the main issues is that you have to have LDAP open and available all of the time on your DCs. It's a protocol that you have to leave open. You can't firewall it. And basically, it means anybody in the organization can at least read sensitive information. Now, many users can also have modifier attributes and permissions for other operations. But the main thing is that it's very hard in Windows to audit these things and control them. You have to leave it open. You can try to manage it maybe with like user permission and things like that, but it gets very convoluted. And there's no easy way to get audit logs for this. So we have on one side the protocol that has to be open, and you have a bunch of different attributes that are very sensitive. So, for example, entity security descriptor is an attribute that holds information about the ACLs and permissions. Things like allowed to act on behalf of and allowed to delegate to are used by, for example, Bloodhound to create those nice graphs. Um, there are attributes that attackers like to modify, so SPNs, key credentialing are used by different attacks. You can even create, delete objects. Those are all potential issues. And obviously, LDAP is used in a lot of different attacks and a lot of different attack tools. So Bloodhound does a lot of its discovery using LDAP. We have attacks like Kerberos, Sting, Shadow Credentials, Evil GPOs. All of these things behind the scene use LDAP. And this is why we created the LDAP firewall. As I said, it's very hard to control LDAP natively in Windows. So we created a tool, an open source tool. You install it on the DC, and basically it lets you do two things. One of them is audit all of the LDAP operations. So we'll get events, including the type of operation, the different attributes, filters, things like that, and information about the user that performed the action and the network information, so the IP address and port. And also based on those operations, you're also able to create rules to allow or block the operations based on your configuration. We'll take a deep dive later into some real-world examples of configuration, but generally you are able to say things like, I only want this group of users to create this type of operation, or only this IP to be able to communicate with my LDAP on specific operations, things like that. So if we take a look at our configuration, basically, it's built like a classic firewall. We have rules, and rules go one by one until there's a match. So we have different things like operations field, which specify this rule applies to one or more operations. So, for example, I want to create a rule that only applies for modify operation. We have the IPs, which basically specifies the source users, which is self-explanatory, groups, DN, attributes, and things like that, which are more specific to LDAP. So, for example, I can create a rule that says, I don't want to let anybody modify specific attributes. And then before that, I maybe can create a rule that says, if I have an incoming LDAP operation for my management server or for a management user, I want to always approve that. Other than that, any other user shouldn't be able to modify a specific sensitive attribute. And then after that, I just want to audit the request to not break anything, but still get logs for everything that happens on my LDAP. And after that, after everything's running and we have unconfigured, we'll start getting logs in our Windows event. So here, for example, at the top, we get what type of operation happened. So in this case, it's an LDAP add operation to add a new object. On the bottom, we have the network information, so which IP performed this operation. And we have our users. In this case, it's an administrator user that tried to add a new computer, and it was blocked because of our configuration. Now, there are a lot of different attacks and a lot of different information online regarding LDAP. I curated some links that is relevant and discuss different LDAP attacks. There are many out there. So these are some nice resources if you want to read more about the LDAP and specifically LDAP attacks. Also on our blog at zeronetworks.com, we have a few blog posts that discuss specifically how to stop these different attacks using the LDAP firewall. Getting started with the LDAP firewall is pretty easy. All we really need to do is go to our GitHub page at github.com/zeronetwork/LDAP firewall. You can find all of the files, the releases, and a lot of information on the README page. So here we have links to different blog posts, some of them discussing how to use LDAP firewall, some of them more deep dives on different attacks based on LDAP and how to stop them. We have some links to video tutorials, including one from previous DEATHcon that we did. And then it goes into the different ways of how to use the LDAP firewalls, how to prevent specific attacks, and things of that nature. You can also take a look at the example config folder, where you have a bunch of different configs for different things. Namely, the most comprehensive one is probably the DACL baselining and prevention config, which you can use to baseline and block DACL attacks or LDAP-based attacks. We have some of these in our actual config that we have on our server, so we'll take a deeper dive look at it later on. And of course, to get started, you can just go to the release page, download the latest zip file, and download it to domain controller server that you have. It should be DC server 2016 or up. Now, here we are on the DC server. This is from the DEATHcon workshop. And we already have the files here, and the firewall is running. So first thing we can do, just go and run LDAP firewall manager /status. And we can see that the LDAP firewall is already installed. If it wasn't, all we really need to do is do the /install and it install everything. It's pretty simple. Now we can take a look at the actual config that we have here on the server. So you can see that we have this config.json file. Can open it. It's such a JSON file, so any text application will work. And we can see that basically it's all built like a classic firewall where we have a bunch of rules, one after the other. And whenever an operation, an LDAP operation comes in, basically the LDAP firewall tries to go over the rules one by one. And whenever there's a match, whatever that rule says takes precedence. So if we take a look at these rules, for example, these first rules ignore basically any operation that is done locally based on the users. And what it does is allow it and doesn't audit it. The reason that we have this rule here is because there's a lot of LDAP search operations that happen behind the scene and a lot of different operations in general that happen locally on the DC. And we don't really want to audit that because it'll make a lot of noise. And also, if the attacker is already on the DC, it doesn't really matter. It's already game over, so might as well ignore that. We have the same thing, but for IPs. And we also whitelist the different DCs just to make sure that DCs can communicate with each other with no issues. Worth to mention that this config is basically following the PE guideline where we first want a baseline. So you'll see that there's no actual block rule. These are all audit rules. So we're trying to get to some baseline where we are only logging attacks or things that we suspect to be actual attacks. So next we have a specific rule to try to detect SOPound, which is the SOPound in the filter. Then we have a bunch of different attributes that are used by Bloodhound. So we can see admin count, allowed to delegate to, ADM PWD, and all of these different attributes using the scope of subtree. So when Bloodhound queries the DC, usually the query will look something like this. It creates a subtree search and asks for these different attributes. So if any of them hits, we should get a log for that. And there's a good chance that's actually Bloodhound running. After that, we have something similar to catch modifications of attributes that we know that are used in different attacks. Again, we have our blogs if you want to read more about those, but you can see all of these different attributes that if any of them is being modified remotely, that's usually a sign to be concerned. Of course, if that will happen locally on the DC itself, then it will be ignored. It will never reach this rule. So it shouldn't break anything. And you can always add more rules before this one. If you have like management servers or some tool that is supposed to be doing these things, you can kind of whitelist that by adding a rule prior to that. But in this case, we're just auditing it. And then we have a bunch of different things to catch Kerber roasting, to ignore some searches we know that are not malicious. So in this case, if we have base searches, which are very limited in scope, we don't want to audit those because, again, this can create a lot of noise. And then some other things that we identified. Some of them are specific to this lab. Some of them are more generic that we just want to audit, just to reduce some of the noise. And then finally, we have a rule that says anything else, we want to allow it and audit it. So if an operation comes in and doesn't match any of our known queries, we always want to allow it, and we always want to audit it, just so we can investigate it later. So now that we have this config running, we can go to our event viewer. Under application services logs, we have LDAP firewall, and we can see what an event actually looks like. So in this case, we have an LDAP search operation. The user that performed this operation is this, a-fw. The action was allowed. The search was performed on this DN. So from this DN, using the one level scope, there's the filter that was specified, the attributes that were requested, the actual IP that performed this query, and so on. Now, let's say we actually want to move into a prevention mode. So let's say we have here this bloodhound fingerprinting. All we really need to do is go here. All we need to go is go here and add action block. Once we have that, any query that comes in that performs a search for subtree with one of these attributes will be blocked. Now, to get it actually running, we go back to our CMD and use the update command. And once that's done, basically the configuration has been updated, and now any request like that will be blocked instead of just audited. And if you want to use Sentinel in the lab, we created this function called get LDAP firewall events. We can write it just to see some queries that have been happening in the last 24 hours. So we have all of these things here. We already parsed them to get all of the different information out of it. You can also take a look if you want on how this is actually built. So we have this function here. Basically, what it does is just takes the parameters that come in from the event log, adds some extra information, and then just parse the different information based on the type of operation. Each operation has different types of data, so it parses the relevant thing, then creates new columns for everything and returns the data. And that's it.
So this is great. So now we understand how to set up LDAP firewall in prevention engineering mode. Let's do the same for the RPC firewall. So if you're not familiar with RPC, RPC stands for a remote procedure call, and it's basically what it sounds like. It means a client calls a remote procedure on a server, just like you would call a function. And the way that it works in Windows is through a mechanism called RPC. And that server can be on the same process, it can be on a different process, or it could be on a different computer, which means that the RPC call will go over the network. Maybe just to give you guys a practical example from the Microsoft documentation, let's open here the Microsoft documentation for remote registry. And inside the remote registry documentation for RPC calls, we can find, for example, the unique identifier, the UUID, that says this identifier means that the RPC call is going to call the remote registry interface. And we can even drill further and look at even specific functions. And we can see that each function has its own opnum, operation number. And this opnum, this combination of UUID and opnum tells the server exactly which interface and exactly which function is being called by the client. And this function, these RPC calls can be transported over SMB, over TCP, over HTTP, and so on and so forth. Now, what's something that most people may not realize about RPC is that RPC is used almost in every Windows service. So for printing, task scheduling, domain control management, user management, directory replication, for remote management using DCOM or WMI, and the list goes on and on and on. So obviously, if you can call all this function remotely, this is very attractive for attackers as well. And this is why we see RPC being utilized over and over and over again by attackers. We see it in certified pre-owned attacks, remote scheduled task for lateral movement, the DC sync attack that we've seen, PSExec, and so on and so on and so forth. The list just goes on. So obviously, we would want to have a method that protects us against these types of attacks. And this is what the RPC firewall is for. Now, the RPC firewall wasn't the first RPC firewall. Actually, Microsoft already has a built-in mechanism using RPC filters that can help you block specific RPC call. So somebody did think then when they were developing RPC that's a good idea to have RPC filters, but there's a lot of problems with the RPC filtering mechanism. Mainly, it's a little buggy, so you can't rely on it sometimes. It's not as granular as the RPC firewall, and the only advantage that it has is that it's built in and that it can help you using RPC filters protected processes. Through the RPC firewall, we expose both the RPC filters mechanism and the RPC firewall mechanism, so you can basically choose which one to use based on your configuration. You can use both, you can use one or the other. And the bottom line is that unless a process is running as a protected process, you don't really have a reason to use the RPC filters mechanism. So you might as well use the RPC firewall because it's more granular. It allows you to use wildcards. It's better at identifying the source IP of the client doing the RPC call. So you might as well use the RPC firewall. For only the protected process, you can use the RPC filters. The RPC firewall relies on a simple configuration file. And that configuration file tells it how to audit certain RPC calls and whether to allow or block certain RPC calls. Depending how you configure the RPC firewall, it will behave differently. So you can tell it, for example, only to audit specific protocols and specific opnums on a specific UUID, a specific RPC interface. You can tell it to block all RPC calls coming from a specific SID, for example. So that would be a user or a group, whichever secured identifier you have in your environment. And the list goes on. You can create infinite amount of configurations. And the way it works is from top to bottom. So each line is a configuration rule, like a firewall rule. The RPC firewall checks it out. If there's a match, it makes a decision. If not, it goes down the list to the next rule. If you put an audit on the RPC filter or the RPC firewall, it will generate audit events. So the RPC firewall events, we can see them on the right, and you'll see they're a bit more robust and more user-friendly than the built-in Windows security event that correlates with RPC. So it will show you the correct client network address and port. It will show you the operation number that was called, and the authentication information is a bit more user-friendly to read. And if you want to read more about RPC and the RPC firewall, there's a lot of content out there. We linked here our GitHub page and a recent blog that we wrote about certified pre-owned attacks that you can check them out, and a couple of videos so you can also check them out and get started from there. So now that we talked about the RPC firewall, let's see how we can get to prevention engineering using the RPC firewall in a very similar way that we did with the LDAP firewall. And it's even pretty much simpler than what we did with the LDAP firewall. Okay, so to get started with RPC firewall is very simple. Simply go to the GitHub page, as we can see here. I really recommend taking a read and going through this GitHub page because it has a lot of useful information. Most of it we covered in this workshop, but some things can be new. Also links to various videos that we've done in a Black Hat talk. You can also find our Slack link here, so you can join the community of people who are using our open source tool, including the RPC firewall and the LDAP firewall. Ask questions, get more information, share information. So I really recommend doing that. And then to download the RPC firewall, you simply go to the release page and get it from there. Now I've already downloaded and installed the RPC firewall in the dev lab. We can see it here on one of the domain controllers. And the first command that I like to run on every RPC installation is the status command. So here, for example, we can see the division between the status of the RPC filters and the status of the RPC firewall. On both occasions, it's not installed and there are no relevant filters and there's no relevant firewall configuration. We do see that even though we didn't install it, we do have the RPC messages DLL installed. This is just because there are multiple users on the server and somebody can hold this DLL, which makes it hard for the RPC firewall manager to delete it. But it's not that important. It's something that can happen, but it's not a huge deal because this DLL doesn't change that much, and it's fine that it's there. So after we see the status of the RPC firewall, one of the other commands I really recommend using is the interface command that we see here. What it does, it lists out all the RPC interfaces that there are RPC servers listening to them remotely, meaning over TCP or SMB usually. And it gives you a lot of information around those RPC interfaces. So one of the things that is we note here, for example, we see the process 528 listening on two types of bindings, one on TCP port 135, one on pipe called endpoint mapper. So this is over SMB. And we can see there are several interfaces that this process is listening to. Another interesting thing that we see is that this process is running as unprotected. So we can defend it with a RPC firewall model. This is not true for this process, which you can see it has the WinTCP Lite protection, which means we can't inject the RPC firewall into it. So only for those interfaces for this process, we will have to use the RPC filters in order to protect them. And going down, we can see that this is basically the only, or there are two basically processes that are running as protected, which have RPC servers running on them. that we can't protect them with the RPC firewall. All the other processes, we can use the RPC firewall, so this is good. Now, normally when you start off with RPC firewall configuration, you can use the built-in configuration that comes in when you download the RPC firewall. This time we'll start with a little bit more advanced configuration. We'll actually use a template, and you can find those templates in our GitHub page. You have templates just for the filters, just for the RPC firewall, and you have one for both. I do recommend starting from scratch and building it yourself because it will be more tailored to your environment. But sometimes, maybe just for testing, or if you want to start out with something that's already kind of works for 90+% of use cases, you can start off with the template. It could be just as good. So here I'll use the template in the both configurations, so both for the RPC firewall model and the RPC filters model. So as you can see, the configurations start off with a bunch of interfaces that we simply want to allow. These are sort of benign interfaces that we've seen in many environments, and we know that there aren't really well-known attack vectors over those interfaces. So what we're going to do, we're basically going to say, you can see there's a FW column at the beginning of each line, which means this line is meant for the RPC firewall model. You can see the action, which is allow, because we're allowing the RPC call. And we can see the audit, which is false. And the reason we're doing false audits because we want to be focused only on those events that are suspicious that we should be blocking using prevention engineering. So that means that we only audit quote unquote bad RPC calls that we're interested in. Next, we have the DC server allow. So those are all the rules that allow RPC traffic from other domain controllers, because there's a lot of sensitive RPC calls that are being called between domain controllers, and these are fine. We could create more granular rules here, but for the sake of simplicity, I think allowing DC to DC communication over RPC is good enough. If an attacker already compromised the DC, a domain controller, you're probably in other troubles. And then we go on for different RPC interfaces, and for each interface we do the same thing. We're allowing it, we're not auditing it. We're basically marking out all of the regular and normal interfaces we would expect to see in each domain controller until we get to the end of the document. And in the end, we have a default block operation. So it's in quotes because it's not actually blocking. The only difference is that it's still allowing the RPC traffic, but it's also auditing the RPC traffic. So what it means that eventually if we go to Sentinel or Splunk, wherever we are forwarding our Windows events, we will see only audits of potentially bad events. So iteratively, we can keep creating this configuration over and over again, make it a little bit better. And once we feel it's good enough, we can turn this default block into an actual block. So it will audit the RPC call, but it will also block the RPC call. So we won't only be auditing bad behavior, but we will actually be preventing and blocking various RPC attacks, just like we saw in the demo earlier. So after we review the configuration, all that is left to do is install the RPC firewall. And after we install it, we start it. And once it's started, we'll go back to our status command just to confirm that everything was installed and it's running correctly. For the RPC firewall, we can see all the processes that it's protecting. And for the RPC filter, we can see all the different filter rules that were taken from the configuration file. Now, if we'll go back to Sentinel, We've created a function called getRPC firewall events that you can run to query the RPC firewall events. This function is based on this query that we can see here. It's basically taking the RPC firewall event logs, it's extracting the different columns from it, and it's adding on some more information like the name of the interface, a short description of the interface. It's also filtering out local RPC activity. So some RPC does happen over the network, but locally on the same server. So we want to filter those out because local RPC calls are not that interesting for us in terms of prevention engineering. And we replace this entire query with a function that pulls those RPC events. So basically, if I'm pulling those RPC events, what we can see here that I haven't seen any new events, which means in the past 48 hours, that was good enough. So it didn't write any suspicious RPC events. But if I'll expand the window, window a little bit for 3 days, we do see some results in the logs. So that means that if we would have made a default block in our configuration, a lot of RPC operations would have been blocked. So maybe it's not good. So we want to see more exactly which RPC interfaces were called and if they're benign or if they're suspicious. So we can do this with the following query. We can summarize our results by the interface ID and the operation. So here you see there are 3 interfaces that were called, each with a single opnum that wasn't part of the original configuration. And what is left to do is basically go back to the RPC firewall configuration, update it, because in this case, all of those operations seem legitimate. And maybe except for the get key, this is something that happens maybe more rarely. So I've already updated this opnum in my configuration. This is the 76, 77 opnums, and I've done the other updates already. And once we update the configuration, all we have to do is run the update command like we see here. And that's it. The configuration was updated. And now we can continue monitoring our RPC firewall logs, see if there are any new events, see if they're suspicious. And after a week, maybe 2 weeks, if you feel confident enough, you can simply move the default block to an actual block mode, and then you'll be full on prevention engineering mode, blocking all sorts of RPC attacks.
Finally, we'll leave you with some homeworks if you want to get some more hands-on experience with our tools. So first of all, you can just try to run a bunch of different attacks on the DC towards the DC servers and see if you're getting the alerts or the logs that you're expecting to see. Or can use the logs to try to understand better how these tools work. So you can try to do DC sync, sharphound, corner shot, PSExec, evil GPOs. There's a bunch of different things you can do. There's many tools out there that use RPC and LDAP. And this is a nice way to actually run them and try to better understand what they're actually doing behind the scene. What does the RPC calls look like? What does the LDAP query look like? So that's a really good way to actually get to know these tools better. You can also try to implement some detections in Splunk. And of course, always good to install the tools themselves, RPC firewall and LDAP firewall on your own DC servers, just to see just to get a feel of how to install it, how to configure it yourself. Again, run some attacks, create block rules, create some whitelist rules, and all those things. And of course, please share, your findings. If you find any detections that you can add, or any configurations that could block additional attacks, or things that you think should be whitelisted, or things like that, please go ahead and share with us and with the community. And good luck.
So thank you for taking part in this workshop. Please let us know if you have any questions, issues with LDAP firewall or RPC firewall, general question about prevention engineering. Remember, you can always join our Slack channel and give us a shout out or consult with other members of the community. So have a very productive DEATHcon. Bye.